Honda just walked onto the global stage and dropped a bomb the electric motorcycle world didn't see coming. Their CEO confirmed a new water-assisted combustion platform, and he said it with the confidence of a man who believes this tech can end the EV push the industry's been ramming down our throats. This isn't some magical water-powered bike. It's a mechanical system built to challenge battery-driven machines where they're weakest. And if Honda's right, electric motorcycles might not be the future everyone promised you. Stick with me, because by the end of this video, you'll know exactly what this means for your next bike, your wallet, and the road ahead. The CEO bombshell. The announcement caught the entire industry off guard, because it arrived without warning or rumor. During a late afternoon briefing streamed from Honda's main development center, the company's chief executive stepped into view and delivered a statement that immediately rewrote expectations for the next decade of motorcycle engineering. He revealed the existence of a new power platform called the V3R 900E compressor water engine, presented not as an experiment or concept, but as an active program aimed at production. There was no hesitation in his tone, no corporate language meant to soften the edges. He said plainly that this engine was built to outperform the electric motorcycles dominating today's headlines and planning boards. The reaction inside the room shifted fast. Reporters stopped typing mid-sentence because they were not expecting anything close to this kind of development. Some watched the executive closely, trying to determine whether the statement was symbolic or literal. Others exchanged quiet glances because the implications were enormous. With a single announcement, Honda had stepped away from the beaten path and pointed toward a direction nobody else seemed prepared to take. This was not a pledge for future battery research or a promise of expanded charging strategy. It was something different, something bolder, and something designed to change long-term expectations. When a company of Honda's size makes such a claim in front of the entire world, the motorcycle industry has no choice but to listen, even if the message lands like a shockwave. But right after the announcement settled, a new question rose to the surface. What exactly is a water engine? What water engine really means? The phrase water engine created immediate confusion because it sounded like something pulled from rumor boards or science fiction channels rather than a real engineering project. As the briefing continued, it became clear that Honda was choosing its language carefully, but the public still reacted with uncertainty. People wanted to understand whether the term meant water as an active fuel, a catalyst, or an integrated part of a broader combustion cycle. Without context, the announcement opened the door to wild assumptions, and seasoned writers do not take well to vague terminology. This is why clarity matters. The moment someone hears the words water engine, their mind might jump to impossible scenarios involving liquid-filled tanks and magical reactions. Others might think it refers to steam-era designs or fringe experiments without practical value. Honda's use of the phrase demanded explanation, because the motorcycle world has been around long enough to recognize when a new term risks being misunderstood. When large companies speak in unfamiliar ways, riders naturally question whether marketing departments are steering the message. Yet despite the confusion, the statement was intentional. Honda wanted the public to understand that the core concept revolves around a controlled system that relies on water in a structured, industrially viable role. It is neither fantasy nor an internet myth, but a deliberate engineering path chosen for long-term development. The label may sound unusual, but the intent behind it is grounded in practical science, not imagination. Still, the timing of the announcement made many wonder why Honda chose this moment to reveal such a direction. If you want straight answers without the corporate filter, make sure you like this video, subscribe to the channel, and share your thoughts below. Your perspective keeps conversations like this honest, and it helps push out the truth writers deserve to hear. The one EV weakness that opened the door. The moment Honda revealed its new engine direction, many analysts noticed something familiar behind the timing. For years, discussions around electric motorcycles have celebrated clean operation and impressive engineering, yet a deeper issue has consistently followed the technology. The challenge is not the motors, the controllers, or the electronics. It is the long, complicated chain of rare metal extraction required for large-scale battery production. Lithium, cobalt, and other essential materials do not appear out of thin air, and their availability depends on mining regions spread across politically unstable areas. Riders who follow industry reports have watched this situation develop quietly. Whenever manufacturers talk about growing electric fleets, a recurring question forms beneath the surface. How many batteries can be produced consistently, and at what long-term cost? The answer has never been simple. Supply chains involving rare metals are subject to price swings, foreign policy disputes, limited deposits, and difficult extraction methods. This weakness does not stop the march of electric engineering, but it lingers in the background, waiting to influence the direction of future design. Honda's announcement arrived in the middle of this tension. While others doubled down on conventional battery production, Honda introduced a system designed to avoid dependence on that same supply chain altogether. It was not framed as an attack on electric technology. It was simply an acknowledgement of a problem the industry has quietly monitored for years, even if few companies have addressed it openly. That leads to the larger question. Why would Honda intentionally step away from the electric rush at this stage? And if you still believe in the feel of real machinery, my road-tested gear and accessories are listed below in the description. Why Honda is rejecting the EV Stampede. Honda's decision to pursue a different path did not emerge from a moment of impulse. Inside large engineering firms, major shifts happen only when leadership believes the current direction no longer represents the future they want to build. For years, nearly every major manufacturer has been racing toward full electrification, following government policies, investor expectations, and competing corporate narratives. But Honda's leadership appears to see something deeper, something rooted in long-term identity rather than short-term trends. The company's decision suggests a belief that motorcycles should retain a form of mechanical character, even as new forms of clean technology evolve. Not every rider wants a silent machine governed by battery limits and software schedules. Some believe the essence of motorcycling involves a power source with personality, rhythm, and a sense of mechanical depth. By announcing the V3R900 e-compressor water engine, Honda signaled its intention to preserve that philosophy while still aiming for future-ready efficiency. There is also an internal strategic layer. Companies rarely choose unconventional routes unless they see an opportunity others have missed. Honda may be responding to market signals hidden beneath surface-level enthusiasm for electrification. Long-term engineers understand that innovation does not always follow the mainstream path, and Honda's choice reflects a desire to protect a legacy centered on engineered motion rather than battery dependency. This move is not rebellion for its own sake. It is a purposeful step toward a future defined on Honda's terms. And the next step is understanding how this new engine actually works behind the scenes. Inside the V3R900 mechanical architecture. The V3R900E compressor engine is built around a straightforward idea, wrapped in a layered mechanical structure. At its core, it uses a compact multi-stage system that begins with a traditional combustion layout, but folds in water injection, controlled thermal chambers, and an electronically managed compressor that regulates pressure with extreme precision. The block houses a tri-cylinder arrangement designed for steady thermal distribution, not peak output, with the main chamber shaped to create rapid heat concentration during each combustion event. Once the heat builds, the water injectors positioned along the upper ring release a finely metered spray directly into the expansion zone. That interaction converts water into micro-steam, not as a primary fuel, but as a force amplifier. The E-compressor mounts to the intake side, but instead of feeding oxygen alone, it stabilizes internal chamber pressure so the water flash process repeats consistently across all cycles. Every component is placed to handle continuous thermal changes without stressing the structure. Honda designed the V3R900 so the engine never relies on water volume alone. Instead, the architecture balances combustion heat, injector timing, and compression management in a closed, predictable rhythm. It is less about raw displacement and more about organizing pressure, heat, and motion with mechanical discipline. Once the layout is understood, the next question becomes which specific performance gap this system is meant to address. The one performance gap. It solves the V3R900 design targets a very specific weakness that engineers have struggled with for years: consistent low-end torque response under variable load. Internal combustion engines often hesitate during the first moments of throttle, especially when rapid acceleration demands a sudden pressure increase. The E-compressor system, paired with water-induced microsteam, is built precisely to remove that delay. When the chamber heat spikes during ignition, the injected water transitions into steam almost instantly, expanding faster than gases created by combustion alone. That expansion fills the pressure gap left between throttle input and full combustion output, smoothing the response. Instead of waiting for rotational mass to build momentum, the micro-steam pulse pushes force outward in the exact window where engines typically stumble. The result is not measured by peak numbers, but by the stability of the torque curve at extremely low revolutions. Engineers refer to this as transitional response, the brief but important moment when the engine decides whether it hesitates or reacts. The V3R900's controlled flash steam pulse does not overpower the combustion cycle. It supplements the pressure in the milliseconds where engines traditionally fall short. This system does not redefine speed or top-end behavior. Its one goal is to eliminate the awkward delay between initial throttle movement and meaningful mechanical output. And it achieves that through pressure management rather than brute force. Understanding that response gap leads directly to the next piece of the puzzle, which is how water, heat, and compression interact inside this cycle. Water, compression, and the fuel cycle. Explained. The foundation of the V3R900 cycle is the controlled reaction between water and chamber heat. As the fuel ignites inside the cylinder, temperatures rise far beyond the boiling point of water. In the fraction of a second after ignition, the water injector releases a calibrated mist, not a stream, into the combustion pocket. That mist flashes into microsteam instantly because the chamber temperature is high enough to cause immediate phase change. The rapid expansion of the vapor increases chamber volume pressure without disrupting the combustion timing. This process does not turn water into a fuel source. It uses the physical properties of steam expansion as a mechanical tool. The engine's E-compressor ensures that incoming air volume and pressure remain stable, so the steam boost does not create unpredictable fluctuations. Once the steam expands, it mixes with the exhaust gases and exits, normally through the valve system. No residue forms, and no separate exhaust treatment is required, because the water returns to vapor and disperses. The cycle repeats with every combustion event, but the injectors adjust their output based on chamber temperature readings. If the chamber cools, the system reduces flow to avoid flooding. If the chamber overheats, it increases mist volume to regulate thermal load. This feedback loop keeps the entire process stable without turning the engine into a water-dependent machine. It is heat management turned into controlled mechanical advantage. But even with a working cycle, the question remains whether this system can scale to real production. Can Honda actually mass-produce this? Turning the V3R900 into a real production engine depends on whether Honda can manufacture the components at scale without overwhelming cost or supply constraints. The good news for them is that the architecture uses familiar combustion hardware combined with precision injectors and a specialized compressor, not exotic metals or experimental materials. The block can be cast using standard aluminum alloys already present in Honda's supply chain. The injectors require higher precision than typical fuel systems, but the company already produces similar hardware for advanced automotive applications. The E-compressor is the only new part requiring a dedicated manufacturing process. It must maintain consistent pressure under thermal variation, meaning tolerances are tighter than average. Still, this challenge falls within Honda's existing turbine and compressor expertise from other divisions. Scaling production would require expanded machining capacity, but not groundbreaking new factories. Water management components are simple, relying on sensors and pumps already common in modern cooling systems. The primary hurdle is not materials or machinery, it is quality control. Every engine must maintain identical chamber temperature readings and injection timing for the micro-steam cycle to work correctly. That demands advanced calibration procedures and strict tolerances during assembly. Honda has the infrastructure for this, but it increases production time. However, from an economic standpoint, the engine's architecture avoids expensive battery materials, complex mineral mining chains, or fragile integrated electronics. Mass production is challenging but entirely feasible. With the engineering foundation established, the next step is understanding how this system changes the rider experience in real conditions, how this affects riders choosing their next bike. Across the riding community, one quiet shift is already underway. Riders who are planning to buy their next machine this season are starting to hesitate. Whenever a major manufacturer announces an entirely new power platform, it sends a ripple through the normal buying cycle. But Honda's reveal created something larger than a ripple. It created a pause. People want to know whether the motorcycles being sold today will hold relevance once the V3R 900 becomes a production reality. Even riders who had no intention of switching brands are watching closely, because the introduction of a new engine class naturally makes the market feel unstable. This uncertainty does not come from hype or fear. It comes from experience. Riders who have been through several generations of engine transitions understand that buying right before a major technological shift can leave them holding a machine that feels outdated quicker than expected. Some are weighing whether to postpone a purchase for one season. Others are delaying without saying it out loud, simply waiting for more concrete details. This hesitation does not reflect doubt in current motorcycles. It reflects caution built from decades spent watching the market move in unpredictable cycles. When a company as large as Honda signals a new direction, even riders loyal to different brands pay attention because long-term ownership decisions rely on stable ground. But riders are not the only ones pausing. Dealership service departments now face their own set of challenges. Dealership service and shop disruption. Inside dealership service bays, the announcement of the V3R 900 has already started rearranging priorities. Technicians who normally work within familiar maintenance routines must prepare for an engine layout that uses water injection, thermal monitoring, and pressure-regulated components they have never serviced before. While the basic structure remains rooted in combustion principles, the supporting systems demand new tools, updated training, and revised diagnostic sequences. That means service managers are reviewing their equipment lists and realizing many of their current instruments will need replacement. Specialized compressors, heat mapping sensors, and injector calibration rigs would become standard requirements for any shop intending to service this engine once it reaches the market. Even shops that have excellent mechanics must adapt because the repair process no longer relies solely on mechanical intuition. Water mist systems require different cleaning protocols. Thermal cycle components demand temperature-specific inspections. The E-compressor assembly needs precision-level alignment whenever it undergoes service. These adjustments are not impossible, but they shift daily operations. Dealerships must also consider parts sourcing. Components tied to high-pressure injection and chamber cooling cycles will not be interchangeable with traditional hardware. Inventory must expand, and wait times may increase during the early years while supply stabilizes. None of these developments are deal breakers, but they introduce friction into a system accustomed to predictable workflows. And while dealerships are rethinking their service procedures, electric motorcycle companies are confronting a very different type of disruption behind closed doors. Before we continue, take a second to subscribe. This channel digs into the stories most companies hope riders ignore, and you will want to be here when the next round of revelations hits. Stay connected so you never miss what comes next. How EV brands are reacting behind closed doors. Electric motorcycle manufacturers are not discussing the V3R 900 publicly, but internal reactions are far from calm. Behind conference room doors, Leadership teams are studying the announcement with a mix of frustration, disbelief, and quiet concern. They spent years building their strategies around the assumption that every major brand would ultimately follow the same path toward battery-driven platforms. Honda's decision to break from that expectation forces these companies to reconsider the stability of their long-term plans. Inside meeting rooms, teams are running scenario models and reviewing development timelines. Projects that once looked secure are now being questioned. Some companies may freeze secondary programs until they understand whether Honda's direction will affect regulatory frameworks, investor confidence, or consumer expectations. Engineers who have spent years refining battery systems now face leadership pressure to analyze whether a water-assisted combustion cycle threatens the narrative many electric brands depend on. This reaction is not fear of the technology itself, it is fear of shifting momentum. Electric-only companies rely on a unified industry direction to maintain growth. A major competitor stepping outside that lane creates strategic turbulence. It forces executives to ask whether they prepared for alternatives or overcommitted to a single vision. In some rooms, the mood is tense because the foundation they built their identity on no longer appears uncontested. However, corporate reactions are only part of the fallout. Regulators now find themselves scrambling to determine what this new engine even is. Regulators scrambling to define this engine class. When Honda introduced the V3R 900, it did more than surprise riders and manufacturers. It forced environmental and transportation agencies into a position they tried to avoid at all costs: classification uncertainty. Regulators rely on familiar categories to process certifications, emissions documentation, and mechanical compliance reviews. A water-assisted micro-steam expansion cycle does not fit neatly into any existing definition. It is not a standard combustion engine, yet it is not a hybrid, and it does not meet the criteria for alternative fuel classifications currently written into regulatory code. This uncertainty has pushed agency divisions into emergency reviews of engineering briefs, legal standards, and past rulings to see if the current rulebook can cover a design like this. The challenge is that the engine uses water as a mechanical element, forcing regulators to decide whether it fits an existing category or requires a new one under their present framework. As these teams debate definitions, paperwork begins to slow. Approvals that used to move predictably are now paused while analysts determine whether upcoming models might require new testing protocols. This hesitation reflects a deeper issue. Bureaucratic systems struggle when innovation steps outside established boundaries. The final step is understanding how these ripple effects change the broader future of the motorcycle industry. How global markets are interpreting the V3R reveal. Across different regions of the world, the V3R 900 announcement is being received through very different lenses. In Europe, where engineering tradition carries long cultural weight, the reaction has been quiet but intent. Industry watchers there are studying the mechanical structure rather than the headline, trying to understand how the system fits into their long-standing respect for precision machinery. Many see the reveal as a sign that alternative paths to cleaner propulsion still exist, even if they do not follow the common line of development seen over the last several years. In Japan, the tone is more personal. The country views Honda's decision as a reaffirmation of its engineering identity. Japanese manufacturers have always balanced innovation with mechanical discipline, and this announcement signals a willingness to push technology forward without abandoning the kind of machine-based craftsmanship the nation values deeply. It is not celebrated loudly, but it is respected as a deliberate, culturally aligned choice. In South America, riders view the reveal with curiosity, seeing a possible shift in future availability. In India, where two-wheel travel dominates daily life, analysts are watching closely, believing Honda's move could shape long-term product strategy before the technology even arrives. While global markets interpret the reveal from afar, factory floors face a much more direct impact. Workforce and industry employment shifts. Inside manufacturing plants, the announcement of the V3R 900 has already begun altering expectations for the workers who keep the industry running. This engine design requires new types of assembly skills, including precise injector calibration, temperature system installation, and compressor alignment that cannot be handled with the same ease as traditional combustion hardware. For longtime factory workers, this means retraining sessions, updated certification programs, and a new rhythm of work that depends on accuracy rather than repetition. Aging mechanics now face a tough choice as water-assisted thermal systems demand new skills late in their careers. Some will adapt, others may step aside. Younger technicians must learn hybrid thermal methods from day one. Labor needs are not shrinking, only shifting towards sensors, pressure checks, and precise micro-steam calibration. As the workforce adjusts, the financial world is already calculating the long-term ripple effects. Long-term economic ripple for consumers and investors. The introduction of a new engine class always triggers financial speculation because it affects product cycles, investment priorities, and long-term pricing structures. When Honda confirmed the V3R900, analysts immediately began modeling how this shift might alter market behavior over the next several years. New technology tends to extend development timelines, which often delays the introduction of updated model families. Investors watch these cycles closely because product gaps influence stock valuations and factory output. For consumers, the impact grows slowly as a new engine design reshapes future models and resale values. Investors view the V3R900 as a long-term asset, signaling Honda's intent to chart its own course. That independence attracts those seeking stability, instead of companies reacting to shifting industry trends. But beyond the financial consequences lies a deeper question about what this change means for the identity of motorcycling itself. What this means for the future of motorcycling culture. When Honda's chief executive stepped forward and announced the V3R900, he did more than introduce an engine. He opened a conversation about what the soul of motorcycling becomes when the machines we ride start shifting in unfamiliar directions. For many riders, the identity of a motorcycle has always been tied to the character of its engine, not just its mechanics. Sound, vibration, rhythm, and mechanical personality form the emotional core of riding. A water-assisted micro-steam system challenges that definition without erasing it. This technology keeps the engine's character alive, blending combustion with a new thermal pulse that feels unfamiliar yet still mechanical. Riders may question whether it marks evolution or departure, but the V3R900 holds onto heat, pressure, and timing. And that brings us back to Honda's defining announcement. So that's the real story behind Honda's new water-assisted engine, and what it could mean for the electric future everyone keeps trying to sell us. Whether this tech really ends the EV push or just gives riders another path, one thing's certain: the next few years are going to get interesting, and I want to hear from the folks who've actually put miles on real bikes, not corporate analysts. Drop your thoughts in the comments. Would you ride something like this? Or are you sticking with what you know? If this breakdown helped you out, hit that like button, subscribe, and stick around. We've got more truth coming your way.